Hello everyone, welcome back to the channel. This is Shailesh SH. Now onwards, I'm going to start the topic from NSR. In that, I'm going to discuss about the SN1 and SN2 mechanism from the chapter of haloalkanes and halorines. Some of my students there are requesting to make a videos on this, so let's go for this. You may find a number of videos on SN1 and SN2, but in this video, I'm going to clearly mention what are the things are there and its application and what are the questions they can ask based on this. I'm damn sure you can't get the examples what I'm going to explain in this. Okay, so better try to focus more on this. First and foremost important thing is that what do you mean by nucleophilic substitution reaction. We are aware about that substitution. इसका मीनिंग क्या होता है, एक पार्ट ऑफ द मॉलिक्यूल को दूसरा पार्ट ऑफ द मॉलिक्यूल आके सब्सटीट्यूट कर रहा है, उसको रिप्लेस कर रहा है. दैट ओनली वी कॉल इट एज सब्सटीट्यूशन. एंड व्हाट इज सब्सटीट्यूटिंग हियर? न्यूक्लियोफाइल इज सब्सटीट्यूटिंग. हाउ? Listen carefully. I am going to write down reactions which is having alkyl halide and I am trying to react with OH minus which is a nucleophile. Now in the presence of solvent always reactions occur. It may be a liquid form, it may be gaseous form, not a solid. Okay, in this what happens generally, negative charged species will come and attack on the positive charged species. Sir, where is positive charge? See, halogen is a good living group. Once it left the group then it become X minus, so this is a good living group. Especially iodine is a good living group. I will explain later, just understand. Once the living group left from the group, then R will get positive charge. Therefore, nucleo can easily come and attack on the positive charge of alkyl group. Then the product is what? ROH plus X minus. This only we call it as nucleophile is substituting halogen. Therefore, in the presence of halogen, we are getting OH. In the place of halogen, we are getting OH. Then, here R is what? If there is any positive charge formed on the alkyl group, we generally call it as substrate. Please keep in mind. X we already know it is a living group. OH is a nucleophile. Solvent में दो तरह रहता है. I will explain later. Just remember, one is polar solvent, another one is non-polar solvent. We'll discuss this also individually. No need to bother about this. First, we'll go for the substrate. When we are getting substrate, first point, how a substrate formed? When halogens are leaving, it takes negative charge with it. It takes negative charge and it form what? Positive charge. On whom? On alkyl group, that is R group, right? Here we have some example, try to understand. If I am mentioning 3 example in this, first one is tertiary carbocation, second one is secondary carbocation, third one is primary carbocation. You can see over here, right? What is the difference between among these 3? First thing we know, it is a degree. Now what do you mean by SN1 SN2? I will explain later, but understand first substrate का role क्या है. जितना स्टेबल सबस्ट्रेट रहता है, कीप इन माइंड, जितना स्टेबल सबस्ट्रेट रहता है उतना अच्छे से न्यूक्लियोफाइल आके इसको अटैक करता है. देयरफॉर कंपेरेटिवली कार्बोकैटायन ऑब्वियसली इलेक्ट्रॉन पुअर स्पीशीज है यहाँ पे, and whatever CH3 they have given, that is electron donating group, so it is generally donating its electron to the carbocation, so it becomes stable. In the first case, in A molecule we have 3 methyl group, means 3 donor group, so it is more stable compared to 2 methyl group compared to 1 methyl group. I hope it's clear. So this is how you need to remember. If the stability of the substrate is more, always keep in mind attacking of nucleophile is easy. If attacking of nucleophile is easy, now you people tell me, rate of SN1 is what happen? Rate of SN1 reaction will increases. You keep in mind this one better, right? This only we call it as SN1. We'll discuss later that one, but understand directly I am mentioning here SN1 को help करता है if the substrate is more stable. I hope it's clear. Example number 2. Same you can see. Whatever the halogen is there, living group, you just remove that one. What it is going to form? It attaches to this carbon, remove this. You're going to get a positive charge on this carbon. You're going to get positive here. You're going to get positive here. This is secondary carbocation. This is tertiary carbocation. This is 1 degree carbocation. Now only I told substrate जितना ज़्यादा stable होता है उतना attacking of nucleophile is very easy. Then SN1 rate will be more. I can write directly SN1 rate, but you are not understanding me. Just mention good living group. Substrate कौन अच्छा है और कौन ज़्यादा stable substrate है. We already know that tertiary carbocation is more stable than secondary than primary. Therefore answer is what? स्टेबल कार्बोकेट सबस्ट्रेट कौन सा है? पहला बी है बिकॉज इट इज़ हैविंग टर्शरी कार्बोकेटन, देन सी है, देन ए है. दिस इज ऑर्डर ऑफ स्टेबिलिटी ऑफ सबस्ट्रेट. सो स्टेबिलिटी ऑफ सबस्ट्रेट इज डायरेक्टली प्रोपोर्शनल टू SN1 रेट बोले तो आई कैन राइट डाउन बी सी ए. आई होप इट्स क्लियर. नाउ वी विल कम बैक व्हाट यू मीन बाय SN1 reaction. We'll discuss one by one related to the nucleophile also, protic solvent also, non-polar protic solvent also. We'll just jump now to the SN1 mechanism. What do you mean by SN1 mechanism? First and foremost thing you need to remember, what is S, what is N, what is 1. S is nothing but substitution of what? Substitution of a nucleophile. Then 1 is what? 1 is a molecularity we used to say. How we are getting that one? Just let's go once. You will understand the example. I am taking the example of tertiary butyl bromide. Why you are taking this one, that also I will explain. Listen. Tertiary butyl bromide undergoes hydrolysis with aqueous KOH. KOH dissociated as what? K plus OH minus. So OH minus is now acting as what? Nucleophile. Where it will go and attack? To the substrate. कार्बन के ऊपर अटैक होकर ब्रोमीन निकलता है. It is a good living group. Yes. So we got what? We left with tertiary carbocation, which is forming tertiary carbocation. So it is obviously, I told now only that it is more stable carbocation. Then obviously nucleophile easily attack. I hope it's clear. Then this OH minus will come and attack, bromine goes, therefore you are getting tertiary alcohol also. What is happening? It is substituting what? Bromine by whom? By nucleophile. That's why you call it as nucleophilic substitution reaction. And why you took tertiary carbocation sir बोले तो because of simple reason उसका stability ज़्यादा है. Therefore generally we used to write SN1 reaction के लिए tertiary carbocation is more stable than secondary carbocation is more stable than primary carbocation. Factors I will explain later, just you need to remember these things only. इधर just hint दे रहा हूँ एक, आप थोड़ा ध्यान रखिए. This is all about the SN1 stability order with respect to carbocation. Then sir, reaction is directly forming in this way. How the mechanism occurs? I hope these reactions you understood. Go for the mechanism once. First and foremost important is that formation of carbocation. How this formation of carbocation occurs? As I told now only, there is a tertiary butyl bromide. Whenever this bromine is trying to leave, obviously there is a formation of carbocation. This is the first step, keep in mind. And the energy which is required to break the bond of carbon and bromine is more. Therefore, it is a slow step reaction which actually play as rate determining step. So directly or indirectly, we got again tertiary carbocation, which is trigonal planar shape along with sp2 hybridization. You got again bromine as a what? Leaving group. Right? This is the first step. What is the first step? Stability of carbocation, which is acting as an intermediate also. Keep in mind there is only one intermediate is there in this SN1. Step 1, formation of carbocation is done. Yes. Step 2 what says? Step 2 says the nucleophilic attack of OH to carbocation to form the tertiary butyl alcohol. Now only I told, right? Carbocation form होने के बाद अगर अच्छा nucleophile है तो obviously it will go and attack on the carbocation, then it is forming the tertiary alcohol. I hope this much clear. There are two steps. One is formation of carbocation. Second step is formation of nucleophile with the substrate, that is RNU also you can mention. The way here carbocation tertiary wala is combining with OH. This is how the second step is involved. On what basis we can mention like this? We know that bond energy need more to break. I mean एक bond को break करने के लिए we need more energy, that only we call it as bond energy more. To form a bond, energy is not required that much. Why? Because already they are trying to become stable. So stable होना है तो वो लोग उतना वेस्ट नहीं करते एनर्जी, उधर कम एनर्जी नीड रहता है. टू फॉर्म बॉन्ड एनर्जी इज लेस. यू कीप इन माइंड दिस 2 points. Why you are telling this one? Understand here. Rate of reaction depends only on concentration of substrate. First understand, rate is directly proportional to over here substrate only. आप Rx लिखो नहीं तो substrate लिखो. Sir, why can't nucleophile? Why not nucleophile? You will understand later. Just understand now. Only substrate के ऊपर डिपेंड है, न्यूक्लियोफाइल के ऊपर डिपेंड नहीं होता है. In this, if I remove the direct proportionality constant, you are going to get an equal symbol, that is rate constant into Rx. Power is what? Nothing. 1. So if nothing is there, 1 will be there. Therefore, kinetic order for this is 1. Then molecularity for this SN1 is going to be 1. Therefore, we call it as SN1. 1 is what? Molecularity. So we can expand SN1 as unimolecular nucleophilic substitution reaction. I hope this much example you understood. And second point, when it comes to the graph related, focus more on this also, it is also important. Unimolecular nucleophilic substitution, nothing but SN1. Now only I mention about 2 steps. One is formation of carbocation, another one is formation of RNU bond. Always keep in mind this is going to be a transition state 1 where bond formation is happening. Step 2 is, bond breaking is happening in the first transition state because Rx was there initially and now it become dissociated as R plus and X minus. This is bond breaking. Second transition state is bond forming. We have to remember these 2 points. With respect to this only I am trying to draw the structure. Now you people tell me. Now only I mentioned bond energy more for what? To break the bond. Therefore energy ज़्यादा चाहिए बोल तो I am just mentioning over here. On transition state like that I am mentioning. When it comes to the second point, bond formation. It does not need that much energy, no? No need more energy because you can see here that R plus Nu minus is there. They both will combine automatically. No need to give more energy to this. Paidaishi they want to become close. Therefore, they are becoming, they are making the bond of RNU. So bond formation के लिए कम एनर्जी चाहिए, इसीलिए इससे के कंपेरेटिवली मैं थोड़ा इधर ड्रा करता हूँ. So here we got 2 transition state. One is TS1, another one is TS2. So transition state 1 किसका था? Alkyl head of bond breaking था ना, इसीलिए I am trying to mention the way like this. Then second one is going to be like this. One second. Like this we are going to get the 2 transition state. One is in this place, another one is in this place. What we are getting by this, sir? By this we are understanding that the delta H, enthalpy from ground state to higher state कितना है, we will understand for the TS1 and TS2 also we are going to understand. This we call it as SN1 mechanism with respect to energy level diagram. Potential energy versus progress of the reaction, keep in mind. Transition state how many are forming? 2. As above reaction I told, intermediates कितना है? 1. Therefore always आप लोगों को ट्रांजिशन स्टेट फाइंड आउट करना है तो इंटरमीडिएट्स को आप 1 से ऐड करो, यू आर गोइंग टू गेट ट्रांजिशन स्टेट. एग्जांपल सुनो. हियर आई एम मेंशनिंग अगेन पोटेंशियल एनर्जी वर्सेस रेट ऑफ रिएक्शन और प्रोग्रेस ऑफ रिएक्शन. Hypothetically if I am mentioning, this is hypothetical, if I am mentioning there are 3 transition state, then how many intermediates? I told now only